Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the distribution function technique, and this is a method that you can use to obtain the PDF of a continuous random variable. So the method here is specifically for the case of continuous random variable. And the steps here are described as such. The steps are quite easy to do. We have two major steps, and I'm going to explain to you what the steps are all about. Well, first of all, let's assume that we have random variables such as x1 or x2 until xn. And imagine that these random variables can be combined, such as they can be added or subtracted or multiplied, and the process here will give you a new random variable. So the new random variable here is going to be called y, where y here is a function that contains either x1, x2, and so on. So here is a function that is related to all the x's here. So the combination of all x's here will give you a new random variable, and we're going to call this new random variable as y. So when you have a new random variable, you might be interested to find what's the probability density function. So what is the PDF of this new random variable? And in order to do that, in order to find what's the PDF, then you have to follow the steps given here. The first step is to find the distribution function. Well, as the name or the technique here suggests to you, the name here is a distribution function technique. So therefore, you have to deal with finding the distribution function. Distribution function is denoted by big F, and I'm sure you have learned or you remember seeing this notation here in the earlier chapter, in chapter 3, where I have thought about the difference between the small f and the big F. So big F here is also known as the cumulative distribution function, and this is what we are looking at. We are going to find what is the big F. So we want to find what's the big F for the new random variable that we have here, random variable y. And mathematically speaking, if you want to find what's the CDF of that, it is the same thing as finding the probability of our random variable y. So this is our random variable, taking the value of less than or equal to small y. So small y here is a specific value, and when you talk about cumulative, you're talking about this process here having less than or equal to. And in order to get that result here, we can replace y with this function here that depends on x. So you're going to replace y with this guy, and this guy here is the combination of all x's that you have. Or if you have just one random variable, then that's just the combination, the specific random variable of x. Okay. Okay, so that's the first process. So by doing this, you'll be able to get what is the distribution function, so the big F. Once you have obtained the big F, what you can do is you're going to differentiate this big F here, and you'll be able to get the PDF. So you will get the probability density function, and this is the process which you have also seen in chapter 3, where if you have a distribution function and you are asked to find the PDF, what you have to do is you have to differentiate the big F. Okay, so not something totally new or strange. You have seen it before. And so without further ado, we're going to look at one or two examples here, so that maybe with those examples you are able to understand more about this technique. Okay, so here we have the probability density of x given by this equation here. You can see that our random variable x takes values between 0 and 1, and this is the PDF. And we have a new random variable, we call it y. Y is just equal to x cubed. Okay, So y depends on x. X is a random variable, therefore y also is a random variable, and therefore we are interested to find what's the PDF of it. And the answer is given as such, and I'm going to show you how you can get this answer, okay? Now, first step is to find the distribution function. Step 1, find what is big F for this random variable. And mathematically speaking, we can do this process of finding the probability that our random variable, big Y, takes value that is less than or equal to the small y. This is small y, so this is small y. Yeah? And we are going to replace y with this one here. Okay, so here we've got x cubed is less than or equal to y, and we need to make sure that we only have x on this part here, so that we can apply the knowledge that we have done in the previous chapter. Okay, so we need to make sure that x becomes a subject. So what we need to do is, we know that x cubed is less than y. Therefore, how do we get rid of 3 here on the top? We can get rid of it if you introduce 1 over 3. Okay, exponent 1 over 3. And on this side also, you have to do the same thing. Okay, 1 over 3. By doing that, you can get rid of 3 and 3. So here we've got x is less than y 1 over 3. So this is the cube root. Okay. Let's write down the result. So it becomes x less than y 1 over 3. X is a random variable. This is a random variable, and we know the PDF is given by this. So if you want to find the probability, it's just the process of integrating the PDF. Okay, this is something that you have seen before, and we're going to substitute the limits accordingly. So here is less than or equal. So this one here is going to be the upper limit, y 1 over 3, and the lower limit is going to be 0. You can see that x is between 0 and 1. So that's the process, and we're going to do this process right now. Okay, so let me just erase this part. I'm going to continue the process next to it. Okay, so here what we have is 6 is a constant, can take it out. Next we can expand this part, so it becomes x minus x squared dx, y 1 over 3 and 0. Okay, and then we are going to get, this is quite an easy process, we can integrate that easily. So we get x squared over 2 minus x cubed over 3. The limits are as such, and we're going to substitute all the limits. So here we have y 1 over 3 squared minus y 1 over 3 3. Okay, and if you substitute 0 into all this, the terms just disappeared. So that's all that we have, and we just need to simplify that. Okay, so here it becomes y 2 over 3 over 2 minus this one here, you can get rid of 3, so y over 3, which can be simplified as 3 and then minus 2y. So that is the first step of finding big F, the distribution function for y. Okay, now the second step is we're going to use this function in order to get the PDF. So we're going to differentiate the result and you will get the PDF. Okay, step 2. Okay, I'm going to differentiate the function. What is the function? The function is this guy. Okay, we're going to differentiate this. Okay, and then the result here is going to be, well, if you differentiate this part here, you get constant outside 3, and then you're going to multiply that with a constant 2 over 3y. On top here is going to be reduced by 1 minus 2, and if you simplify that, you will get 2y. 2 over 3 minus 1 is negative 1 over 3 minus 2. Factor 2 out. Okay, so this is the result. And we need to know the PDF here is for y. So this is the PDF for y, which is equal to fy. And we need to know the limits of y. So here is applied for y between what value and what value. This is what we need to come up with. Well, in order to answer that, the information that we need is as such. We need to know first x is between 0 and 1. So we know that x is between 0 and 1. And we also know that this part here is the representation of y with regards to x. Here we know that y is equal to x cubed. And we have shown that in order to relate x and y together, we already show that x is equal to y 1 over 3. Okay, so we're just going to replace y 1 over 3 on this part here. So I can say that therefore y 1 over 3 is going to be greater than 0, less than 1, right? Based on this result. Okay, now we don't want y 1 over 3, we want just a simple y. Okay, simple y. Therefore, what you can do next is you can consider this part. So for example, you can consider y 1 over 3 is greater than 0. So how do you get y? In order to get y, you need to introduce exponent 3 on both sides. So by doing that, you can cancel out 3 and 3. So therefore, y is greater than 0. Therefore, we can write the result here. Y is greater than 0. Next, we're going to focus on this part. So here we have y 1 over 3 less than 1. Again, we're going to follow the similar idea. Introduce exponent 3, which can be cancelled out. So y becomes less than or equal to 1 as well. So here is the result. Okay, therefore this result here is true for values of y such that y is greater than 0 and y is less than 1, and this is the result demonstrated right here. Okay, now let's move on to perhaps another additional example here. Okay, here we've got the probability density of a random variable y is given as follows. We have PDF of y, and here y represents the amount of diesel stored in a given week in a local Petronas station. Suppose that the storage tank at the station holds 10,000 gallons, then 10,000 y will give you the number of gallons stocked in a week. So what does it mean is that you can see our random variable here can only take values between 0 and 1. 0, 0.2, 0.25, 0.13678, any value, continuous value really. Okay, the value is continuous from 0 to 1. So therefore you can see that let's say y is 0.5, therefore the amount of diesel that they have at the station is going to be 5,000 gallons. Okay, so 10,000 times 0.5. Well, of course, if y is equal to 1 is the maximum value, then you will have 10,000 gallons, and that is the maximum value that the station can hold. So of course, when y is 0, that means the station doesn't have diesel at all. Okay, so that's how it is, the relationship between y and this part here, 10,000 y. Okay, and the PDF is given by this one, and the rest is going to be 0. Now, if the current price of diesel is 3 ringgit per gallon and there are fixed delivery costs of 2,000 ringgit, then we have the total cost to stock 10,000 y gallons in a given week is given by this random variable c. So c here is a random variable, Why is it a random variable? Because it depends on a random variable. Y here is a random variable. Y here can take any value between 0 and 1. That's why it is a random. So when C depends on Y, which is random, therefore C is a random variable. Simple as that. So when C is a random variable, you may want to find what's the PDF of C. Okay, so we want to know what's the PDF of C. Okay, all right. Now this C here is equal to 30,000 Y plus 2,000. So that is the value of C. Okay. Now, in order to do that, okay, so let us continue the process here. We want to find the PDF of C, and the process is going to start with finding what is, okay, the first step is to find what is the big F for small c here, specific value of C, okay. So the big F for C is going to be equal to probability of big C, the probability of our random variable, takes a value that is less than or equal to small c. So this is a specific value. This is our random variable. So we want to know what's the probability our random variable less than or equal to a certain value. So if you want to know, like, for example, what's the probability that x is less than or equal to 3, or probability c is less than or equal to 2.5. So here is the random variable, and this part here are the numerical values, specific numerical values. Yeah. Okay, so what we're going to do is, again, we're going to replace C with what we already know, which is related to Y. Now, why do we want to replace C with this guy? This is something related to Y, is because later on we can use this information here. This information here is related to the PDF of Y. Okay, so we're going to replace C with this part, okay, this function here. This is the same thing as finding the probability of, well, 30,000 Y plus 2,000 less than or equal to the small c. Okay, and we need to make Y as a subject. So what we have is, well, we know that 30,000 Y plus 2,000 less than or equal to C. Therefore, 30,000 Y is less than or equal to C minus 2,000. And so Y is less than this guy over 30,000, which is going to be Y less than C over 30,000 minus 2 over 30. Okay, so that is our Y. Okay, so we're going to write that here. This is probability of Y less than or equal to C over 30,000 minus 2 over 30. And we already know how to find this probability based on what you have seen in chapter 3. So here is the process of integrating function y, because here is our random variable y, and our random variable y has the PDF as such. Okay, so we have 3y squared, integrate it with respect to y. The limit here is going to be this one. This is the upper limit, less than or equal. So less than or equal means it's going downwards. So here is the upper limit, c over 30,000 minus 2 over 30. And the lower limit is going to be 0. So that's the lower limit. Okay. Next, 3 is a constant. We can take it out. And this is quite easy. We just do it straight away. Okay, so here we have the result is 3y to the power of 3 over 3, and the limit is such. Okay, cancel out. Next, what we have is the result, c over 30,000 minus 2 over 30 to the power of 3. So that is our big F. Okay, now let's look at the next step, which is to find the PDF, okay? Okay, in order to find the PDF, step 2, find the PDF. We're going to differentiate this result here with respect to C. So we're going to take this result and differentiate it with respect to C because we want to find the PDF of C, yeah, of the new random variable, which is C. And this is C over 30,000 minus 2 over 30 to the power of 3. And we already know how to differentiate this. So here is going to be brought forward. So here we got 3 C over 30,000 minus 2 over 30. Here we're going to reduce the power to 1, so to the power of 2. And next we're going to differentiate inside the inside part with respect to C. So if you differentiate that, if you differentiate this part here, it's going to be 1 over 30,000. And this part here is a constant, so the result here is 0. So that's all. And we can simplify that to be 1 over 10,000. And then we have C over 30,000 minus 2 over 30 to the power of 2. So that is the result, the PDF. And we need to know what's the value of C. So this result here is 4. What's the value of C? C between what value? So this is what we need to find out. Okay, and in order to find that out, we need this information. We know that y is between 0 and 1. So we know that y is between 0 and 1. And what is y? We have shown you that y is related to C in this manner. So we need to know what is y in terms of C. Well, y is this one here. So we have shown that y is actually equal to C over 30,000 minus 2 over 30. This is the value of y. How do we know that? We can obtain from this part. Okay, C is 30,000 y plus 2,000, and therefore y is just C minus 2,000 and then over 30,000, and which can be simplified as C over 30,000 minus 2 over 30, and that is my y. Okay, therefore I can write down here, therefore 0 is less than or equal to, going to replace y with C over 30,000 minus 2 over 30 less than or equal to 1. However, we don't want something that looks complex like this. We just want what is C. We want to know what is C. Okay, so what we have to do next is, therefore we can consider this part here, this part first. We can say that therefore C over 30,000 minus 2 over 30 is greater than or equal to 0. C over 30,000 greater than 2 over 30, right? Therefore C greater than or equal to 2 over 30 times with 30,000. Okay, so you can cancel out 30 with 30 at the bottom. 2 times 0, 0, 0 is 2,000. Therefore C is greater than or equal to 2,000 for the first part. Okay, we're just going to look at that one. Next, we're going to consider this part. Okay, so here we have C over 30,000 minus 2 over 30 less than or equal to 1. C over 30,000 less than or equal to 1 plus 2 over 30. Okay, next C is less than or equal to 1 plus 2 over 30 is actually 32 over 30, right? 30 plus 2, so 32 over 30 times with 30,000. Again, 30 here can be cancelled out with this at the bottom, so C is less than or equal to 32,000. Okay, so this part here is the PDF for C. So this is the PDF for C, where C here can take the values. The minimum value is 2,000, the maximum value is 30,000. Okay, that's it about the distribution function technique, and thank you very much for watching.